Hi, kids. Unit 1's over. Yay! It's over! You know what? Time to celebrate with some Dunkin' Donuts coffee. When I finish Unit 1, I drink Dunkin' Donuts coffee. When I start Unit 1, and I'm in the middle, and the end, and the beginning, and, well, I just keep drinking coffee. Got a problem with it. Anyway, this part is the stuff we're going to do in class with you, but we're not going to get through it all. And quite honestly, it's probably going to be a little bit more guided review. You're going to be working on it on your own, trying it on your own, and see how you do. This will be your answer key. So my name is Mr. Key for today. There you go. By the way, all these videos can be found at www.nkinfinity.com. And I should be organizing them at mrkraus.math.com as well. mrkrausmath.com as well. Hopefully that'll come up eventually. I don't know. We don't know. Let's get rid of that one for now. We're not sure. Maybe it'll be there. Who knows? Anyway, let's get started. The students in one of the technology classes here at Hilton High School will be launching rockets made in class. The Mike Healy launched from the ground, traveling at a height traveled the highest in class. Clearly, I'm a math teacher because English is a second language for me, apparently. I don't know. I can't read today. The rocket followed a path modeled by this. Which of the following would be a realistic domain and range for this function? Okay. So, in this case, domain is time. And range is height. We'll go H-E-I-G-H-T, hopefully. Range is height. So let's just height. All right. So what's it going to look like? Well, if you draw it, and you think, okay, it's going to start somewhere down here, right? And then it's going to take off, go up, 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 and then come down, 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 and hit the ground again, right? So at some point it'll be at its highest. Now, how long would a rocket last? Now, these are high school rockets. They're not going up for any length of time, you know what I'm saying? We're going to start here at time probably 0, right? And end at like 5 seconds, 10 seconds, I don't know. Maybe it lasts for 10 seconds. Oh, so from 0 to 10 would be a good domain. That means we're down to these two. Wait a second. Time is 10. So this is time, domain. I'm a little miffed here. I only have one domain where there's time for 10. How about, well, let's just see if the range makes sense. Range would go start at 0 and go up, I don't know, 100, 200 feet, something like that. I don't know. Well, okay, maybe the range going up 100 feet would make sense. It starts at 0, goes up to 100. So that one's the only one that makes sense. Which of the following functions is graphed below? Well, quite frankly, this absolute value, this one right here is probably the easiest one to take care of. Or this one. This is just 2. I don't know what this one is. But this is just the line y equals 2 or f of x equals 2. Not sure what this one is. But I know what the vertex is. The vertex is over here. It's going up. And it's going up by 1. So there's no number here. It's just 1. X. We move to the right 4, so that would be minus 4. Remember, that's backwards, and down 3. So I'm looking for minus 4 down 3. Nope. And nope. See how this one has a minus 4 down 3? It also, wait, this one has a negative, though, out front. So since that has a negative, that one can't be as well either. So it appears as if this one is the right answer. Not sure, though. Let's just check. Let's just check. So this one, if it's correct, should go from negative 2 to the right, not including negative 2. So x is greater than negative 2. That looks good so far. Should be 2 from negative 4 to 2 and including the 2. Negative 4 to 2, including the 2. And this one is coming down by a slope of 2. And it looks like I screwed up somewhere. But Yeah, it looks like that's the right one right there. There she is, kids. My hero. All right. And let's see about this one. Remember, this stands for inverse, right? And inverses are really just reflections over y equals x. So if I was just to draw the line y equals x in and say, okay, I'm going to reflect this over this, wouldn't it look something like that? So now I'm like, okay, they look like reflections of each other. Let's see. Nope. That's a good one. Nope. And nope. Looks like this is our winner right here. Number 2. All right, that's it. Oh, yeah. So we got through 3 questions. Caught me again. All right, check it out. All I want you to do is tell me whether or not it's a function or not. If it is a function, I would like you to tell me if the inverse is a function, and then I want you to tell me how you know. Oh, you also should be able to tell me it's a one-to-one function. So, remember, a relation, man, having a hard time talking this morning. A relation is a function if it passes the vertical line test. This one is for the VLT. One-to-one means it passes the VLT and the HLT, but it can't even be a function if it doesn't pass this one. So the big kicker is, is it going to pass the horizontal line test? Well, this fails the vertical line test just about everywhere. So this is not a function. So let's check the next one out. The next one is a function. Yes, it is a function. But more importantly, wait a second, is it a one-to-one function? It clearly passes the vertical line test, but it is not a one-to-one function because it fails the horizontal line test. Oh, go back to this. If the original function is not a function, clearly its inverse is not a function. No. You don't have to worry about that. Oh, I don't even have to answer that question. It's not even a function. If it is a function, is the inverse a function? No. In order for it to, how do I know? Because must be one-to-one if, oh, not if. In order for inverse to be a function. To be a function. Woo! Man, having a hard time this morning, kids. Sorry about that. Fails the vertical line test, not a function. Passes the vertical line test? Yes. Passes the horizontal line test? Yes. Is the inverse a function? Yes. And then this one is simply because it is one-to-one. Is this a function? Let me see. If I draw a line down here, it hit that point, but remember, that's like an open circle there, so it kind of just goes right through it. Like a basketball hoop, goes right through it. Same thing here. So yes, it is a function, but it is not a one-to-one function because it fails the horizontal line test right there. So it is not a one-to-one function. So if it is a function, no. All right, moving on. What we got? All right. What is g of -1? Remember, these are x equals -1, and they're really asking you for what is the y value. So really all you got to do is say, okay, g of -1. Here's where x equals -1. G is 0. Let's see, 6. 6 is right here. 7. Oops. Probably should get rid of this stuff. 7 is my answer. G of -7. Oh, that's 1. G of 3. That's right here. Well, that is 3. That's not too difficult, is it? That stuff should be, yeah, no problem. Okay, let's try this again. So, I think maybe what I'm going to want to do, I say again because I just done it twice and I wrote the wrong answer down twice. I don't know what I'm doing. So what we're going to do is we're going to grab our graphing calculator and we're going to graph this thing. So the function is -1/3 x minus 4. So that's what it looks like. But we can only go from -6, which is over here, to 0, which is over here. So I'm going to go look at the table. Oops, escape. Control T. And I want to see what the value is at -6. At -6, it's -2. And at 0, it's -4. And it's just linear. It's only going from, Control T. It's only going from here down. So the range is from -2 to -4. So I got to do, but here I can equal. So -4 less than or equal to y. But here, because it's got an open circle, I can only go less than -2. All right. So on this one, it's a little bit different. I'm not going to do this one graphically. That was just a linear function. That was pretty easy. This one I'm going to slide over here off to the right. I'm going to just draw a quick sketch of this. So it's y is equal to 2 absolute value of x plus 2 minus 1. So if I draw a quick sketch of this, I'm going to go left 2, down 1, right there. Okay. And it's going up by 2s. So up 1, 2 over 1, up 1, 2 over 1. So at x equals 0, it looks like it's equal to 3. That's the highest, it's 3, at 3. But I don't know about this 6. 1, 2, 3, 4, 5, 6. So we're going to go up. Well, maybe it is in my best interest to graph it because I'm not going to know exactly where this value is up here at -6. So maybe I do want to graph it. Let's red X it. Let's not save it. And we'll do 2 absolute value of x plus 2 minus 1. Enter. And then maybe it's in my best interest to see, hey, what's going on at x equals -6? We're going to Control T, say, what is the value at -6? By the way, at 0, there it is 3. And at -6, it looks like it might be 7. So this y value here is y equals 7. So the highest, so it's going to look like this. So the highest it's going is 7, and that's at -6. But the lowest is the vertex, which is down here at -1. So it's going to go from -1, which it can include this. So it's going to go from -1 less than or equal to y less than. I cannot equal this because notice it can't equal the -6 all the way up to and not including +7. That was a kind of tricky one. That was a difficult one. Hopefully you got through that one. Alrighty. Let's see what's going on. This next one's not too bad. I think this is all this is transformations. Oh, what the heck just happened? I think we're going to here. We're going up. Going over. Okay, so it says, given the following two functions, determine all of the transformations that were made on each of them and compare them to the parent function of this. All right. So this number in front 2, that is a dilation. So it's a dilation times 2. This is a translation left 6. And this last one, it also is a translation down 2. That's all there is to that one. So we got one more thing going on this one. This negative right here, that is a reflection in x-axis. We have the 1/2, which is a dilation of 1/2. That just means it's getting wider. You need to know that. The -3 says we're doing a translation right 3 and a translation up 2. That's it. All right, solve the following systems of equations graphically. All right, so let me do these in two different colors. I'm going to do the absolute value first. We're going to go to the right 5, 1, 2, 3, 4, 5, and up 3, 1, 2, 3. Because of this negative in front, I'm coming down, but it's a -1, so I'm coming down by ones. So I know I'm going to be coming down by ones. Now, drawing on this tablet I use is quite difficult. So I just do this. And this. There we go. All right, let me grab a different color for the other one. And that one we're going to, oh, and I should have called this f of x. Label, learn to label. And this one will be g of x. It's got a y-intercept of -2. And we're going up 2 over 3. Up 2, 1, 2, 3. Up 2, 1, 2, 1, 2, 3. 2, 3. Down 2, 1, 2, 3. So when I graph that one, it looks like this. Now, some of you might be content in just stopping there. But if I stop there, I haven't actually solved this yet. A solve means you need an answer. And in this case, the answer or answers are the points of intersection. So I need to find the 2 points of intersection. That's this one here, which is 0, -2. And this one here, which is 1, 2, 3, 4, 5, 6, +2. Yay! We're getting there, kids. That's number 8. Number 8. Let's see what we got going on. The second term of an arithmetic sequence is 12, and the fifth term is 30. If the first term is a sub 1, write an equation, notice it's an equation, for the nth term of this sequence. This is an arithmetic sequence, so you should know the form of an arithmetic sequence is a sub n is equal to a sub 1 plus n minus 1 times d. Alrighty then. Let's see. Can I find d? I don't know a sub 1, but I probably could find it. But I don't know a sub 1, and I don't know d. So I got to figure out what this is. So sometimes it's in your best interest to just go 1, 2, 3, 4, 5. The second term is 12. And what was I going? Oh, the second term is 12. And the fifth term is 30. That's the second term. Third, fourth, fifth is 30. Well, the difference from here to here is 18. And how many times am I going to add? I'm going to add here plus something, plus something, plus something. So I'm going to add something 3 times. So I got to divide by 3, and I get 6. So let's see. If I add 6, I get 18. If I add 6, I get 24. And if I add 6, oh, I get 30. So now I know that D is equal to 6. Now, if that's true, then finding the first term is actually pretty easy. I'm just going to subtract 6, and I say, oh, the first term is 6. So a sub 1 is 6. So your answer to this equation is a sub n is equal to 6 plus n minus 1 times 6. Okay. Now, if you want to, you could clean this up, and you could have an answer of a sub n is equal to 6 plus 6n minus 6. You distributed this. But of course, this is just a sub n is equal to 6n. So either this or this would be acceptable answers. Either one. Okay, we're going to find inverses. Now, if you remember correctly, finding inverse means we're going to switch. Step one is to switch the x and y. So we're going to replace this with a y. So this is really y equals 3x minus 9. We're going to switch these. Remember, it's just the letters, the variables that you're switching, not the numbers with them. So this becomes x equals 3y minus 9. Now, since my y is positive, I am not going to move it. Not going to touch it. I'm going to move the 9 over, so I get x plus 9 equals 3y. And finally, divide by 3. Divide by 3. So I end up with y is equal to x plus 9 over 3. So your two acceptable answers, make sure you understand this. Your two acceptable answers are f inverse of x is equal to x plus 9 over 3. Or you can have f inverse of x equals 1/3 x plus 3. Either one of these is acceptable. All right, let's do the next one. We'll do it in different colors so we don't change. First of all, we're going to change this to a y, and I'll switch them. So I get x equals negative 2 over 5y minus 1. Well, here's the problem. We've got a fraction. Now, I know you. You love fractions. You're like, oh my God, it's fractions. Can anything make me happier than fractions? Yeah. Coffee, of course. Maybe hitting myself in the head a few times, but certainly not fractions. Nobody likes them. So we're going to get rid of them. And the easiest way to get rid of a nasty little fraction is to multiply through by whatever you want to get rid of. In this case, a 5. So we're going to multiply this side by 5. And we're going to multiply this whole side by 5 as well. Well, that's really distributing the 5 there and distributing the 5 there. Now, once you do this, the magic starts to happen. You end up with 5x equals, now here, the 5s are going to cancel. So I get negative 2y minus 5. Okay. Now, here's our little dilemma. Our y is negative. So because our y is negative, I really want to move it to that side. So I'm going to make it 2y. And then, so now I have 2y plus 5x equals negative 5. So, but I still want y by itself, so I'm going to move the 5x over here. It becomes negative, so 2y equals negative 5x minus 5. Sorry about my phone. Dealing with a lifeguarding issue. So now I got to divide by 2. Divide by 2. Divide by 2. So one of my acceptable answers for this would be f inverse of x equals negative 5x minus 5 over 2. Or you can have f, I got to turn it off, f inverse of x equals negative 5 over 2x minus 5 over 2. I don't really care what you have. I mean, I would just use this one because chances of you making mistakes are much reduced. All right, got one left. I think I took care of it. Maybe not. So another fraction. Who's happy? I am. All right, let's try a different color. All right, let's first change this to a y, and then we'll go. Okay, x equals 3/2 y plus 12. All right, let's multiply through by that. Let's multiply through by that 2 so we get rid of it. So 2, 2, and 2. We're going to multiply everything through by 2. So I get 2x equals 3y plus 24. The y is positive, so I don't want to move it. I'm going to move the 24 over. So I get 2x minus 24 equals 3y. Sorry about that. Divide both sides by 3. Divide both sides by 3, and I get f inverse of x. Now there's two acceptable answers here. 2x minus 24 over 3, which to me, Might as well leave it. But if you ever had to graph it, I guess being able to change it's also nice. F inverse of x is equal to 2 over 3. That's a 3. X minus, now that would give me 8. So those are your two acceptable answers right there, kids. Good. I hope you kicked butt on that. That wasn't too bad. What would I do with my wonderful students? And of course, coffee. All right, recursion. It's a scary word. I know people say, oh my God, it's a recursive sequence. Go home and say, Mom, I'm learning about recursive sequence and arithmetic sequences in so far as much as whatever, and start making it sound really complicated. But it's not. It sounds really bad, but it's not. Basically, recursive sequences just are defined. You're given one value, and each subsequent or each number afterwards is defined using the previous term. So our first term, which is a sub 1, is given as 128. Okay. That's like when k equals, I guess, 0 in this case, but it's our first term. That's our first term. So our second term, which would, I guess, be when k is equal to 1, that would give me a sub 2, right? If I plugged a 1 in there, wouldn't that give me 1 plus 1 is 2, so okay. So it's 1/2 a sub, now remember k is 1 here, 1 plus 8. Well, what is a sub 1? Oh, it's 128. So this is really just 1/2 of 128 plus 8. Oh, let's see. Half of 128 is 64. 64 plus 8 is 72. Okay, that's a sub 2. A sub 3 then is, now this is when k equals 2. So that means, that's why I've got 3 here, right? A sub 3 is equal to 1/2 a sub 2 plus 8. Remember, now k is 2. So that's 1/2 of 72 plus 8. Let's see. Half of 72 is 36 plus 8 is 44. I think you guys get the picture now. A sub 4 is going to be 1/2 of a sub 3, which is 44. 44 plus 8. Half of 44 is 22 plus 8 is 30. And then finally, we get a sub 5, which is the fifth term of our sequence, which is 1/2 of 30 plus 8. Let's see, half of 30 is 15 plus 8 is 23. So there is your answer to the recursive sequence. And it's not that bad. You're just using the previous term to generate the next term. All right, moving on, kiddies. So excited. Oh my God, lots of reading. All right, if you know Sam Minahan, anybody been to Minahan's go-kart racing? It's out there somewhere. I don't know where it is, but it's cool and it's fast. So Minahan's go-kart racing has a pricing structure that is a little confusing, much like Sam. Not gonna lie. Let me try to explain. If you want to ride, the first 4 minutes will cost you $10. So no matter what, you're going to ride for 4 minutes and it costs you 10 buccarinis. And it will tell me it's worth it. It's worth it. Then for every 2 minutes after this, it will cost you an additional $2. I want my $2. Okay, you got to watch that movie. It's awesome. It's called Better Off Dead. It's a movie title, Better Off Dead. It's not a sick movie. It's funny. It's a funny movie. It's with John Cusack. Okay, so the first 10 minutes, no, the first 4 minutes are going to cost me $10. So $10. So I'm going to go up to $10. Now, if I don't ride 0 minutes, it's not going to cost me anything. So I can't put a closed circle here. I have to put an open circle here because if I choose 0 minutes, they can't say, "Hey, you chose 0 minutes. It's gonna cost you $10." No, that's not it. So for the first 4 minutes, it's gonna cost me $10. So if I just go 4 minutes and I don't want to go anything more, it's gonna cost me $10. But then they get you. For every 2 minutes after that, it'll cost you an additional $2. So I'm going to go up by $2. Now notice this has to be an open circle because at 4 minutes, it's still only $10. But as soon as I go a little bit past it, it's going to cost me $2 more, and that's good for the next 2 minutes. And then I'm going to go up by $2, and for the next 2 minutes. Now, the longest I can go is 10 minutes, so I have to stop here at 10 minutes. I can keep doing this, but I got to stop when I get to 10 minutes, which I think is the next one. So there's A. I've graphed it. Now, the last part says is what is the maximum cost of a single ride? Well, the maximum cost of a single ride is this one right here, $16. All right, let's keep going. The relation given by the set 2, 4, 3, 5, 4, 6, 4, 7, 5, 7 is not a function. Eliminate one ordered pair in order to make this relation a function. Explain why you have chosen this pair. So a function does not have repeating x values. So our two problem childs are this one and this one. They both have 4s. So you can eliminate either one. So for this answer, I could say 4, 6, or you can eliminate 4, 7. Either one is acceptable for choice A. Eliminate one of those two, and you now have a function. So is the new relation that you created from part A now a 1-to-1 function? So now, because of the first answer could have been either one, I got to answer this 2 different ways. If you eliminated 4, 6, then no, it is not 1-to-1. If you eliminated 4, 7, then yes, it is 1-to-1. I'm going to explain it in the next part because that's the part that says explain it. A 1-to-1 function has no repeating x or y values. So if I eliminate 4, 6, we have repeating 7s as y values. Notice here, 7s, repeat. But if you eliminate, and I'm running out of space, but if you eliminated the 4, 7, if you eliminated 4, 7, then you have no repeating y values, and therefore it is a 1-to-1 function. Okay, that's what we're looking for as far as an answer for there, and as far as an understanding of that problem. Okay, children, we're almost done. Almost done. Not quite, but we're almost done. Let's check this out. I want to talk about domain. Now, you'll remember domain is left and right. The x values. What are the x values? So it looks as if domain goes forever and ever to infinity. So what I have to look for is, are there any breaks in the graph from left to right? Are there going to be any breaks from left to right? So as I do this, let's see. As I come across, I go negative infinity all the way up to and including -4. But at -4, that's an open circle. But wait, we include -4 up here. So including all of these values up to and including 0. But after 0, it jumps up here, and we still get no breaks all the way up to and including 5. Now remember, the only time I'm going to use y values are down here. That's the only time I'm going to use y values. So, since I had no breaks left to right, my domain is negative infinity to 5, and I include 5. No breaks. Range is up and down, and it's our y value. So let's see. This looks like it's going down to infinity, but it stops here at negative 4, not including negative 4, and I got a break. That's a break. There are no values between negative 4 and negative 2, so I have to, that's a break. So then from negative 2 up to and including positive 2, I'm okay. But then I have another break. I have another break right here. And then I go from, what is that, 3 all the way up to and including 9. So this one's going to be much more complicated. This first piece is from negative infinity all the way up to negative 4. So negative infinity all the way up to negative 4, but not including negative 4. Or, so that's my union symbol, or I go from negative 3 to positive 2. Oh, no, that's negative 2, excuse me, negative 2 to positive 2. Both of which are including. So negative 2 to positive 2, both of which including, or from 3 all the way up to 9, and including both, 3 to 9. So there is your range. Is it a function? Well, does it pass the vertical line test? Is there a place where we have repeating x values? And no, there isn't. I mean, right here, I go through, remember, but we're going through like a big hole here, so it's not going to hit that. So yes, this is a function. Is it a one-to-one function? No, fails the horizontal line test, so no, and therefore its inverse is not a function. Where is the graph increasing? So it's increasing, 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 increasing. So if I was doing this, I would say it's from negative infinity all the way up to and including, remember, we're only dealing with x values, 2, but not at 2. Where is it decreasing? Well, it starts decreasing here, and it starts decreasing and going down here. So that's from negative 2 or positive 2 to 5, not including those endpoints. Now, finally, we get to the place where I want y values. And this is the only place I want you to give me y values. So what is the minimum? Lowest part of the graph. Well, remember, it's going down forever and ever and ever, so my minimum is negative infinity. And the maximum is way up here, which would be 9. All right. So now we got to talk about the piecewise function. Piecewise function. Move this up just a little bit so I can get this in here. We're going to do this. Notice there's 3 pieces. 1 piece, 2 piece, and my third piece. So f of x is equal to. All right, let's do this first piece. Let's figure out what this slope is. Up 1 over 4. Up 1 over 4. So that one's not bad. It's 1/4 x minus 3. Now, I know it doesn't get over there, but I still need that y-intercept to tell me what the equation of that line is. But we know that we're only going to use this piece. We're only using piece 1 here, starting at negative 4 and going in that direction. So we're only going to use that when x is less than, not including, negative 4. That's piece 1. Now, piece 2, I know my domain. I'm going from negative 4 to 0. And the equation of that line couldn't be any easier. It has a slope of 1 and a y-intercept of 2, so x plus 2. And that we're doing from negative 4 less than or equal to x less than or equal to 0. All right, so the last piece is sort of the most challenging. It is an upside down absolute value. So I know it's an absolute value with a negative out front. Now, it's also coming down. It's also coming down 2 and over 1. So not only is it coming down negative, but it's coming down by 2. So 2. Now I got to worry about this vertex. So that's the beginning part of it all. Now I got to worry about this vertex. We move to the right 2. Remember, that's backwards. You're not going to put x plus 2. You're going to put x minus 2. And we moved up 9, so plus 9. So hopefully you got that one right. And that one, we're only graphing from 0, x equals 0, not including that, less than x, less than or equal to 5. Not an easy problem, kids. I hope you did okay on it. Not bad, though. Not bad. Okay, children. Now we get the question about my favorite car, my Chevy Volt. I should take a picture of it and show you, but I won't. So, I have a Chevy Volt. In the past 2 years, I now have had it 3 years, but in the first 2 years, I put about 21,000 miles on the car. And all but about 900 miles were completely electric, which makes it so nice. Actually, I have them a lot. I'm doing even better now. The only thing he doesn't like that is when the weather gets colder, the number of electric miles my car can go is reduced a lot because the energy required to keep the car heated and the batteries from freezing means I can only go less miles. So it uses battery power to kind of heat the batteries and keep the car warm when I'm driving it. So the table below shows the 6 recorded temperatures and estimated mileage from my car. So I want to write the linear regression equation. I want to write the linear regression equation for this data where the temperature driven is the independent variable. All right, so temperature driven, temperature is the independent variable. Round all answers to the nearest hundreds. So we got to do to the hundreds place. Okay, so I'm going to go over to my calculator. We know, always red X things. We know we're going to hit in the spreadsheet. So this is my independent temp. And miles goes here. So let me just use it here. It's 82, 67, 51, 43, 30, and 12. 48, 44, 39, 36, 34, and 31. All right, so there's my mileage. Hopefully I typed those in correctly. I'll know in a minute because I already have the answers here. I'll know in a minute. But one of the biggest mistakes made always on regression is not typing those numbers in correctly. So make sure you do that. So we're going to go over here to menu. We're going to go into statistics, stat calculations. Make sure you pick the right linear regression. It's the one you know the easiest. The one you know the one you're most familiar with. Click on that one. Be careful, this is in alphabetical order, and temperature is the X value. If you pick the wrong one, you're in trouble here. So temperature is the X value, and miles driven is the Y value. So the temperature affects the mileage. So the temperature is the independent variable, and miles is the dependent. And Y is always the dependent. So we click OK. And there they are. Now remember, I want a linear regression model. Well, here's the equation that's really not an equation. And one of the second most common mistakes made is writing just mx plus b. It's y equals mx plus b. So you need to tell me what m is, unrounded. So come over here and click on it. Here it is down here at the bottom, unrounded. So 0.2501. 0.2501 9719. 9719. Good enough. And B equals 2678. 2678. 23000. 23000. So now I want to round my answer to the hundreds place, 2 decimals. I like to highlight that piece It's this one and this one. Decide if you're going to round or not. So my answer is y equals 0.25x plus 26.78. All right. So from this equation in part A, determine the number of miles to the nearest tenth that I can expect to get if it's 48 degrees out. So remember, this is the temperature. That's the independent variable. So all I'm going to do is plug that in for x. So I get y equals 0.25 times 48 plus 26.78. So I come over to my calculator. 0.25 times 48. Yes, I know that's 12 plus 26.78. So 38.78. Round to the nearest. So I'm going to write y equals 38.78 and round to the nearest tenth. My final answer is y equals 38.8 miles. You don't even have to write miles, but I'm putting it there. Now, the next question is a little bit different. The next question says, what is the temperature going to be if I can only drive 42 miles? So, y is the miles. So I'm going to plug 42 in for y this time, and I know it's got to be 0.25 times x, which is the temperature, plus 26.78. So I'll subtract 26.78. So I take 42, was it 42? And subtract 26.78, enter. So I get 15.22. So 15.22 equals 0.25x. Divide by 0.25. And I get x equals 60.88. So x is equal to 60.88 to the nearest tenth of a degree. It's x equals 60.9 degrees. And that's it, kids. That's the end of your practice test. I hope you enjoyed yourself today. It wasn't that bad, I hope. All right, catch you on the flip side. Hit that subscribe button. Hit the thumbs up. It has to be thumbs up. It has to be. Goodbye. Goodbye, students. Goodbye, all you fun kids. Goodbye. No, really go. Go, really go. Gotta go. Bye.